The modern world has become this way because of computers. Every day, each of us uses some kind of software without which we can no longer imagine our lives. In this video, I will tell you about the history of programming and the emergence of computers, about how people learned to give these machines instructions about what to do and how to perform a variety of tasks, from simple addition of numbers to the most complex neural networks, like GPT chat. Here are 10 interesting facts about programming. I suppose a lot of people think that the history of programming began when the very first primitive computers appeared, but that is not true. The first programmer in history was a woman. Her name was Ada Lovelace, and she wrote the first program ever in 1843. She wrote that program not for an electronic computer, but for a mechanical computer. It was called an analytical machine. It was designed by the British inventor Charles Babbage. It was a huge and heavy mechanical product made up of many moving parts, drums, knobs, and so on. This machine even had the ability to memorize. That is, there were cells whose numerical value could change depending on the results of previous calculations in the chain. This machine was essentially a huge mechanical calculator. Calculators had been created before that too. However, this machine could solve very complex mathematical equations that also required formulas. But this machine was never finished in the lifetime of its creator. In its completed form, it existed only in the form of drawings. Unfortunately, Charles Babbage was not able to build the machine completely because of lack of funds and disagreements with his engineer. The machine was partially built after Babbage's death by his son. Nevertheless, the program, that is, the algorithm of the mechanism, was developed by the previously mentioned Ada Lovelace, and this can be considered the first program in the history of mankind. And in 1991, engineers from the London Museum of Science still built the machine using Babbage's drawings. The machine worked exactly as he designed it to be built. The materials used were those that Babbage might have had in the 19th century. The machine was powered by the rotation of a lever and could actually process complex mathematical calculations without error. The first computer in the current sense of the word, that is, a general-purpose electronic computing device, appeared in the United States a couple of months after the end of World War II. War, in general, is often the engine of progress, as people need more efficient weapons. During World War II, long-range artillery was actively used. There were special tables with which artillerymen used to point their guns. Information about wind speed and direction, distance, target heights, elevation of the gun itself, air temperature, air pressure, and even projectile temperatures were used to point the guns. The tables helped to calculate quite accurately exactly how the gun should be set up depending on all these conditions. However, if the design of the gun changed, if some new shells were used, all these calculations for the tables had to be done again, which required a huge number of man-hours, because it was all done manually. In order to automate all this, the first electronic digital calculator was created, which could perform various calculations, depending on the program in use. In fact, it was the first computer, and it was called ENIAC. It weighed 30 tons, took up an entire room, and had hundreds of kilometers of electrical wires. There were no microprocessors back then. Instead, they used special electric lamps. We will not go into detail about how this worked, but what is interesting is that this computer had more than 17,000 of these bulbs. Thus, each day the computer worked only about half the time, while the other half of the day was spent replacing the burned-out bulbs. Even if you're not a programmer, you've probably heard of such a concept as a programming language. But what kind of language is this? Why can't you just write programs in English or other languages? The fact that the computer does not understand human language. The computer only understands machine code. Machine code is a sequence of huge, gigantic numbers of ones and zeros. It is also called binary code. This gives the computer the commands it understands. However, writing programs using binary code is very hard for anyone. It is not easy, and it is not very efficient. That is why programming languages were created, that is, text commands, mostly in English, using various symbols that are understandable to humans. Each such command can be written using ordinary letters and symbols, and a special computer program, the compiler, already translates these human-understandable commands into machine code so that the computer can execute them. Programming languages differ from each other by various parameters: the ease of learning, the syntax, that is, the rules of writing programs in it, the speed and scope of these languages. There are a huge number of programming languages. Some of them are very common, and some of them are rarely used. Many are long outdated. The most popular languages are Java, Python, JavaScript, C++, and others. There is not a single programming language that is good in every way. A programming language that is good for developing computer games is not always good for building websites and vice versa. Relatively easy to learn and use, Python is much slower than the much harder to learn C++. There are no programmers who know all the programming languages at a good level, just as there are no polyglots who know all the languages spoken in the world today. The different programming languages differ in their level of complexity, but there are also languages that are specifically designed to make life difficult for the programmer. The use of this language should be as complex as possible. Such languages are actually created to illustrate the syntax of the language, that is, what the code written in it looks like. For example, in JavaScript, the code for a simple program that displays the English phrase "Hello World" looks simple and succinct. In Python, it also looks simple. However, there are some programming languages like Brainfuck and Malbolgia which are obviously very difficult to use. In Brainfuck, you have to write a very long code to display the phrase "Hello World." It doesn't even contain any letters, just symbols like brackets, pluses, and minuses. Another similarly complex programming language is called Malbolge. The programs written in it look very strange. For example, the code for displaying the phrase "Hello World" looks like a series of mooing cows in this programming language. Another absurdly complex programming language that was designed to be absurdly complex is Malbolge. It is named after the eighth circle of hell mentioned in Dante's Divine Comedy. The code for displaying the phrase "Hello World" looks like this. There are no words in this programming language and it is very hard to understand it. Nevertheless, all these programming languages can be used to write programs. And there are many video tutorials on YouTube for programmers who want to test their skills and master these difficult languages for some reason. Even if you are not a programmer, you are probably familiar with such a concept as a bug. It is a bug in a program, which can either cause the program to stop working, or the result of this program will not be as intended. The word bug translates as insect. It is a term for bugs and malfunctions that predates the advent of computers and software. It was used by Thomas Edison, the American inventor, at the end of the 19th century. He referred to bugs as faults or errors in the design of electrical devices that he created. The term was first used in relation to computers in 1947. At the time, an American programmer, Grace Hopper, working on the Mark I electromechanical computer, discovered a moth stuck in one of the computer's parts, preventing it from working properly. Grace removed the moth and taped it to a log that documented her work on the computer. There she wrote that she removed the insect from the computer, using the word bug to refer to the moth. Since then, software bugs have been referred to as bugs everywhere. Sometimes bugs can cost money or even kill people altogether. In 1962, the Americans launched the Mariner 1 spacecraft to go to Venus to study it. It was supposed to be the first interplanetary flight for us. However, the spacecraft was destroyed 293 seconds into the flight. As the investigation of the incident showed, it was not due to some malfunction of equipment, a broken part, or bad weather. It was something else. A missing hyphen in the command code that controlled the flight of the ship. However, because this hyphen was missing, the onboard computer made the wrong control actions, which resulted in the destruction of the spacecraft. No one was killed, but the cost of this spacecraft was $18.5 million. If you recalculate this amount in modern money, taking into account inflation, it will be about 150 million modern dollars. This was the most expensive defect in history, and taught mankind the importance of full and scrupulous testing of programs before using them in such important things as spaceflight. How to download? Everyone knows that in order to download a program, you have to go to a specific site on the internet and download it from there. Or you can download it from a flash drive, floppy disk, or disk. There used to be application stores, but at the dawn of the computer age, there were programs that could be downloaded directly from paper magazines or from radio broadcasts using a tape recorder and cassette. In the 1980s, there was a computer called the ZX Spectrum. It was a small computer, cheap by the standards of that time. It didn't have a screen. You could use a regular TV instead. Programs for it were sold on audio cassettes. From audio cassettes, you could load programs through a tape recorder into the memory of this computer. The audio cassettes recorded a sequence of sounds. which the computer perceived as a sequence of parameters. In this way, the program code from the cassette was written into memory and became a program. Since programs could be transmitted as a sequence of sounds, they could be transmitted by radio. The radio transmission would be recorded on tape through a tape recorder, and then the program would be recorded on the computer itself. There were also various magazines, and on the pages of those magazines was printed the code for this or that program. At that time, the codes were very simple, and there were relatively few of them, so anyone could just retype the code from the magazine page into the computer. And this way you got a working program which you could then use. A lot of different games were created for this computer. There were many clones of this computer which, among other things, were sold all over the world. It was thanks to this device that the first Soviet gamers were introduced to the first computer games. If you follow the IT world, you may have noticed that there are a lot of Hindu programmers among the big names in the West, especially in the United States. The CEO of Google, Sundar Pichai, is also Hindu. The CEO of Microsoft, Satya Nadella, is also Hindu. There are many other IT companies that are also run by Hindus. And if you speak English and tried to learn programming on YouTube, you might have noticed how many different channels there are with video tutorials run by Hindus. So why are there so many Hindus among programmers? Is it possible that Hindus are born with a +5 in programming, just like a +5 in guru skills? It's actually simpler. The main factors are two things: the huge population of India and the prevalence of English in this country because it was a British colony, as well as the incredible poverty of its inhabitants. The average salary in India for an IT job is very small. It's very difficult to get out of poverty there, but almost every Hindu has some kind of access to the internet and can speak English. Hindus understand that if they spend a few years studying hard at software engineering, they will get a ticket to a new life for themselves and their family. Even if they take the cheapest freelance orders from Western clients, they will get enormous money by Indian standards. India has a gigantic population of billions of 400 million people, and most of them live in unbelievable poverty. That is why so many Indian young people become programmers, because they have no other social elevators and opportunities to make a good life for themselves. Many of them, having achieved success in the field in India, move to Europe and the United States, where they often hold senior positions in large companies. China also has a huge population, and the average Chinese person is also poor. But Chinese programmers are much less common in the West, because the Chinese usually don't know English at all. And the fact that the internet in this country is not as free as it is in India also affects this. IT companies are now making a lot of money because the work of programmers is highly valued. Software is a product that is needed in all areas of human activity. At the same time, it is simply information that can be copied and sold an infinite number of times without spending any resources on it. If the product is already developed, then IT companies selling software can scale relatively easily because they do not need to build additional factories and buy more resources to produce their product. Nevertheless, IT companies spend a lot of money on software product development, support, and code updates. Such software is their intellectual property, so they hide it from the public. Many of them keep it a secret. This approach does not please some people, other programmers who fear, for example, that in this way corporations can introduce their programs with spy features that send their data somewhere without the user's consent. This is why, in the 1990s, a group of enthusiasts founded the open source movement. The idea behind this movement is that software development is not carried out in closed mode by a single company, but in open mode. When all the programmers in the world can see the source code of a program, check it for integrity, and participate in one way or another in its development, and look for vulnerabilities in it. After all, the more programmers test the code and see its structure, the more likely it is that someone will find a bug or vulnerability unnoticed by others, or suggest a better way of writing such code. Nevertheless, such programs can be sold under regular commercial licenses. That is, their source code is open. However, this does not mean that such programs can be used for free. There are also proponents of the idea that software should not be paid for, because it is just information that essentially costs nothing, and access to software, as they believe, is a basic human right. Such programmers collectively develop various programs that are distributed for free. Perhaps the most common such software is the Linux operating system, which can be used on a computer instead of the familiar Windows for most people. Most of the servers in the world run on Linux. Linux is also the basis for the mobile operating system Android. Programming is not only a highly paid and in-demand profession. Programming can also be competitive. There are Olympiads on sports programming. When programmers alone or in a team write programs that must solve a certain problem. The task is given by the members of the jury at the beginning of the Olympiad. Participants write programs and then send them to the members of the jury for testing. Tests are prepared in advance, and what they will be are not known to the participants in advance. Depending on the effectiveness of the program and whether it works correctly, participants are awarded points. Programming competitions are held to select applicants for admission to universities instead of entrance examinations. Also, large IT companies often hold such events in order to find new employees, often among teenagers who have a talent for programming. I think everyone knows that programmers make very good money, but when I was in school, only very specific people worked in this profession. It was not widespread, and the word programmer was synonymous with nerd. Now the situation has changed a lot. The profession has become prestigious and highly profitable. There are even girls who write in their profiles on Tinder that they are looking for an IT specialist. But why do programmers earn so much? The reason lies in the balance of supply and demand. It is not easy to become a programmer. This job requires a long learning process. Moreover, programmers must always learn something new, because technology is constantly evolving. You cannot learn a programming language once and work all your life without learning new things. You also have to constantly find solutions to problems that you just have never encountered before. Therefore, there are far fewer programmers on the labor market than necessary. Plus, the results of programmers' labor make a lot of money for IT companies. When Facebook bought Instagram for $1 billion, Instagram employed just over 10 programmers. That is, with their own efforts, they can create a product that is worth orders of magnitude more than a product created by thousands of specialists in another field. Also, programmers' salaries grow in proportion to their experience. The longer a programmer works, the higher wages he can claim. If the current employer cannot provide this, the programmer will simply go to another one, since the demand for this profession is great. There is no telling how long this state of affairs will last. Once, 30, 40 years ago, lawyers and economists, for example, were very much in demand. And now many people with law and economics degrees work as couriers or cashiers. But so far it seems that the demand for programmers will be very high for a long time to come. Write in the comments if you have ever tried your hand at programming. Your answers are something I read. They're also very helpful in promoting videos. As a continuation of this theme, I suggest you watch my issue about Darknet. It will be interesting. The links are right on the screen. Make sure you subscribe to the channel. It helps me a lot.